Hello dear students, welcome back to my online math class. I am Teacher Ray, your teacher for today. Before we start, I want you to have your math textbook, your copybook, and pen. Before moving on to our lesson today, let's have first your answers for your homework of the previous lesson. Lesson 75, Determine Outcomes of Compound Events. Let's start with your textbook page 389. Practice and problem solving. Number 7. There are 4 stores that sell school supplies S1, S2, S3, and S4, and 3 stores that sell sporting goods nearby, and they are represented by G1, G2, and G3. How many possible combinations of stores could you visit to buy a tennis racket and then a backpack? By using a tree diagram, for the store that sells sporting goods, store 1, we have S1, S2, S3, and S4. For store 2, we have S1, S2, S3, and S4. For G3, we have S1, S2, S3, S4. There are 12 possible combinations. Item 8. A bakery sells wheat, multigrain, rye, and oat bread. Each type of bread is available as a loaf or as a dinner rolls. A. Complete the table to show all the possible outcomes for the types and styles of bread sold by the bakery. So we can have wheat and loaf. We can have multigrain and loaf. We can have rye or loaf. We can have oat and loaf. We can have wheat and rolls. We can have multigrain and rolls. We can have rye and rolls. We can have oat and rolls. So find the number of possible outcomes. So by using the table to show all the possible outcomes for the types and styles of breads sold by the bakery, there are 8 possible outcomes. Number 12. In your textbook, page 390. Plastic souvenir cups come in 3 different sizes. We have the small, represented by capital letter S, medium, capital letter M, and large, capital letter L. The available colors are red, capital letter R, white, capital W, and blue or B. Make a list to represent all the possible combinations of the different cups based on size and color. Write each outcome in the format, size, and color. And here are the possible outcomes. We have SR, SW, SB, MR, MW, MB, LR, LW, and LB. Number 15. Assessment practice. Complete the table to show the sample space of number letter combinations using the numbers 7, 8, and 9, and the letters R, S, T, U, V, and W. So the possible combinations are 7R, 7S, 7T, 7U, 7V, 7W, 8R, 8S, 8T, 8U, 8V, 8W, 9R, 9S, 9T, 9U, 9V, and 9W. How many possible outcomes are there? There are 18 possible outcomes. Today I am going to discuss Lesson 77, Simulate Compound Event. This is in your textbook pages 397 to 402. And here are the objectives of the lesson. Use different tools to simulate a compound event. Model a real-world situation involving a compound event and predict its outcome using a simulation.
How can you use simulations to determine the probability of events? Think about this question during the lesson. Nikki is planning a hike for the end of the week. She really does not want to hike if it is raining the whole time, but is okay if it is cloudy. Based on the weather forecast, should she postpone the hike? To begin, let's develop a probability model for rain on a given day. List the two possible events and their probabilities. The sample space, S, is rain and no rain. The probability of rain is 40%, or 4/10. What is the probability of no rain?
Select your answer.
In every probability model, the sum of the probabilities of the outcomes is equal to 1. The probability of no rain is equal to 1 minus the probability of rain, or 1 minus 4/10, which is equal to 6/10. How can you use a model to represent the situation? Next, we can model the situation by designing a simulation using a spinner. A simulation is a model of a real-world situation that you can use to find probabilities. This spinner has 5 sections of equal size. 2 of the 5 sections are labeled R for rain. The probability of R is 2/5, the same as the probability of rain. The other 3 sections are labeled N for no rain. The probability of N is 3/5, the same as the probability of no rain. Now it's time to run the simulation. Spin the spinner 3 times, once for each day, and record the results. Conduct additional trials. Based on this simulation, Nikki should expect rain on 1 day of the 3 days. She should not postpone her hike.
There may be more than one probability model that represents a situation. Drag tiles to show whether each spinner is a correct or incorrect model.
Now, you know how a simulation can help you determine the probability of an event.
Now it's your turn. Please answer this.
There is a 50% chance that a volleyball team will win any one of its remaining games this year. A spinner with two equal sections numbered 1, win, and 2, loss is used to simulate the probability that the team will win exactly 2 of its last 4 games. The results of the simulation are shown below. 1, 2, 2, 1, 1, 1, 2, 1, 2, 2, 1, 1, 2, 1, 2, 1, 2, 2, 2, 1, 2, 2, 1, 2, 1, 1, 2, 2, 1, 1, 1, 1, 1, 2, 2, 2, 1, 1, 1, 2. Hornets and the Tigers will play a 5-game series, with the winner of 3 games named the state volleyball champion. The 2 teams are evenly matched. Use a simulation to find the probability that the Hornets will win the 5-game series.
Step 1 is to develop a probability model. Sample space as Hornets win and Tigers win. So list the events and their probabilities. Probability of the Hornets win is 50% and the probability of Tigers win is 50%. Step 2 is to design a simulation using a coin. The outcomes and probabilities of flipping a coin can be matched with those of the game. Heads or H is the Hornets win and tails T is the Tigers win. Step 3. Run the simulation. For each trial, flip the coin 5 times to represent the 5 games. Trial 1. H, H, T, H, T. The Hornets win. For Trial 2, the Tigers win. Trial 3, the Hornets win. Trial 4, the Tigers win. Trial 5, the Hornets win. Trial 6, the Hornets win. And for Trial 7, the Tigers win. So step 4 is to find the probability. Based on 7 trials of the simulation, the probability that the Hornets will win the series is 4 out of 7.
An energy bar company is printing equal quantities of 6 different collectible cards. The company will randomly package 1 card inside the wrapper of each energy bar. What is the probability that all 6 collectible cards will be packaged in a box of 10 energy bars? A useful way to solve this problem is to use a random number generator to simulate the situation. Let the numbers 1 through 6 represent the collectible cards. For example, the random number generator may produce this set of 10 numbers. Most of the collectible cards are included, but not card 2. So this is not a full set of all 6 cards. You can use the random number generator to make more trials of choosing 10 cards. In this simulation, only one of the 8 trials resulted in a full set of the 6 collectible cards. Based on 8 trials of the simulation, the probability that all 6 cards will be packaged in a box of 10 energy bars is 1/8, or 12.5%. However, this result is only an estimate of the theoretical probability. How can the estimate be improved? You can use the random number generator to continue the simulation. As the number of trials increases, the results become closer to the theoretical probability.
Now it's your turn. Try to do this.
In a tennis tournament, 25% of Sarah's serves were aces. Design a simulation to predict how many aces you expect Sarah to serve out of 50 serves.
And we are done. Don't forget to answer items 1 to 13. This is in your textbook, pages 400 to 402. Please check your Pearson account for your assigned test. That's all for today. See you in the next lesson.